Hello friends, welcome to our channel. Let's eat pizzas in this problem or video. So here actually we are going to practice indexing. So because this problem is actually super easy. So here we are given an integer array called pizzas of size n. So where pizzas I represents the weight of the iced pizza. So every day you eat exactly 4 pizzas, and due to your incredible metabolism, and when you eat pizzas of weight w, x, y, z, and then if they're ordered, right, you gain the weight of only 1 pizza. So in odd number days, so you get the weight, the largest one. So in even number days, you get the second largest one. So we want to find the maximum total weight we can gain by eating all the pizzas. So here it's guaranteed that n is a multiple of 4, and each pizza can be eaten only once. So this guarantee actually makes this problem rather straightforward. So let me quickly give you an example, and then we do the coding. The plan is that I'm going to do coding first by simulation, and then by indexing, just write a short solution. So here, the first one, so it's actually in sorted order, right? So what we want to eat in the first day, and so first day is starting from as odd, right? 1 indexed. So when we start, we want to eat the largest. So I want to eat 8, digest 8, I guess. So I actually do not care about which 4, right? So I can digest this one. For example, I use this 4, 1, 2, 3, and 8, right? So in the second day, I digest 6. So overall, that will be 14. Actually, this problem is not very very representative. So actually, you can use more. You can use 9, 10, 11, and 12. So this actually you can eat 3 times, right? So if you eat 3 times, it's guaranteed that you can have 2 odd number days. So in this 2 odd number days, I'm going to digest 12 and 11. And then in the other day, I'm going to digest 9. That's the plan. So how do we do this? So let's first digest 12. So we can do this, 1, 2, 3, 12. So digest 11. How to digest 11? So we do 3, 4, 5, 6, and 11, and then digest 9, right? So we have 7, 8, 9, and 10, right? So overall, it will be say 31, right? So 32. Let me check this one first. Let me write past here. So what we do is this. So we can, we have this one, right? Now let's run it. 32, right? So with that said, now we can actually do the coding in a very fast fashion. So first, we can do pizzas sort. So here I'm sorting from small to large, but you can sort from large to small, right? So, and then how many so first you can divide this by 4. How many 4s, right? So let's see, n is the length of pizzas, and then days, let's see, it's n over 4, right? So if days is an even number, so you are going to, for example, just divide by 2. That's number of odd days, number of even days. But if it's odd, like 3 groups, you are going to have 2 odd days. So odd and odds, so will be days plus 1 over 2, and n evens will be just the days over 2, right? So once you have this, and then I just need to for the odd number days, so I digest the largest ones. And for the even number days, I just digest the second largest ones. So how do we do this? So we can do a result like this. So this is some computation. Let me make the code compact. Right, so now we digest to gain weight. So then for this in range n odds, so I just do result increment by pizza. That's pop, right? That's it. So now I want to digest the second largest one. Then basically this is the for this in range n evens. So what I do is this pizzas pop. So this we cannot digest. So this is what we want to digest the second time, right? And then you just need to return the result. That's the solution. Actually, this is exactly what I analyzed. Just to transform it to code. So now let's check that. Yeah, it passes the two test cases. So now let's look at the generic case. Yeah, it passes the cases. So here, actually, if you look at this code, so let's translate them into one that just use indexing. So here you can regard this one as a, say, simulation, right? You sort, so this is the O(n) logarithm n, right? And then you do this pop. So this is essentially linear, right? So overall, it will be O(n) logarithm n. N is the length of the pizzas, right? So now let's look at the second one. So second one, we just use some indexing. But for this, it might be, you need to pay attention to the start and end. So similarly, we can do pizzas sort. So, but this time I want to do, let's see, reverse. I'm not going to use a lambda function now here. Reverse is true, right? We sort in place, but from large to small. And then we compute the number of odds and the number of even. So same as above, right? So here, let me introduce this in length of pizzas. So this is just for convenience. So then you can, from this n, you can get the days or groups. So it's n over 4. And then odds, so let me use just odd. And maybe days plus 1 over 2. And even is going to be days over 2, right? So we get this even and odd. Then we just return sum of those things. So pizzas. So then we need to digest all those. And then we just to digest the others. So pizza. But just, so odd we cannot. So currently it end at index odd minus 1. So we need to start from odd plus 1, right? Pizzas, odd plus 1. And then, so we need to digest, so this number of evens. So, but the step will be 2. That's it. So here, let me change this one to be version v1, and this is the version v2. So here I wrote in some redundancies. For example, all those 4 lines, you can just make it 1 line if you like, right? But this is the writing short code is not our purpose here. So if you put this one above, and then you can shrink the below 4 lines into 1 line. Oh, that's very straightforward. So then you can just return this indexing. But my purpose here is to explain how to use this indexing. So now let's check that. So it passes the 2 test cases. Now let's look at the generic case. Yeah, it passes all the generic case. Seems it's very fast. But however, again, the time complexity does not change because we are using sort. So overall, it will be O(n) logarithm n. This n is the length of the pizzas. So here it's roughly linear, right? So with that said, I guess that's it for the current video. I guess pizza is delicious, so the problem is also delicious and easy to eat, right? Thank you.